Picture this: cities drowning in noise, an incessant 80-decibel hum from endless construction and snarling traffic. That single skyscraper you see, it can churn out over 100,000 tons of waste, which is like filling 20,000 garbage trucks. Delays are the norm, with 90% of big projects running late, costing billions. And on site, it's dangerous work. 1 in 10 construction workers gets injured. So it's no surprise that 70% of these projects stretch out by an extra 18 months. Those sites often blast noise at 90 decibels, as loud as a jackhammer. Then there are the hundreds of daily truck deliveries for materials, jamming up roads and spewing CO2. The construction industry is also grimly responsible for 20% of all workplace fatalities each year. We're facing a massive skilled labor shortage too. 500,000 fewer workers needed in the US by 2026, which just inflates costs. These methods guzzle energy too, consuming over 30% of the world's primary energy. Mistakes and rework eat up another 10 to 15% of project budgets. Add in bad weather, which can stop outdoor work 20 to 30% of the time, and you've got costly chaos. These long builds block vital city arteries for years. Juggling thousands of parts from hundreds of suppliers creates a logistical nightmare. So, how do we build smarter, faster, and with less of a mess? This promised to slash on-site construction time by 30%. Project managers envisioned a future where construction waste plummeted by 70%. Budget predictability would also soar by 15% during every major build. This bold paradigm shift, championing off-site manufacturing, was championed by visionaries like Dr. Sheila Patel from MIT's Urban Futures Lab in 2018. Modular units, 90% complete with finishes and utilities, would be manufactured in controlled factory environments. Think Legos, but for actual skyscrapers. This strategy reduces construction traffic by 80%, easing urban congestion and noise pollution for thousands. Precision engineering in factories ensures higher quality control. Engineers studied traditional construction for 30 years and are still not okay. These modules often integrate smart building technology, like 5G connectivity and IoT sensors from inception. Project planning moves from years to just months. Digital twins simulate every assembly step 200 times. That is like running 200 Olympic races before the starting gun. The London Crossrail project, for example, adopted modular components for 10 new station structures across the city. This adoption drastically cut on-site work duration by an estimated 60% compared to traditional methods for constructing complex underground stations. Modules are built to exact specifications, with tolerances as fine as 2 millimeters. That is thinner than a credit card's width. These advanced factories operate year-round, unaffected by weather, boosting overall productivity by 40% over traditional sites. Subscribe if you think innovation in construction has hit its peak. It has not. Workers in these climate-controlled environments experience 70% fewer safety incidents. Automated testing stations in the factory, robots perform pressure tests, thermal scans, and electrical checks. Split screen, ground crew preparing foundation, factory producing modules, both progressing in parallel. Picture this: a full 30% shaved off project timelines, all thanks to factory-built modules. This future isn't unfolding on messy construction lots, but inside sophisticated manufacturing hubs. There, a staggering 90% of a building's structure gets built before it ever sees daylight, completely insulated from weather and chaos. Imagine an entire apartment or a whole hotel floor crafted with factory precision in as little as 7 to 10 days. Meanwhile, traditional builds are still wrestling with blueprints. These sterile environments guarantee components fit within millimeters. Once fabricated, these modules, some weighing 50 tons, like moving a very large, very solid house, are carefully transported. On location, massive cranes orchestrate their rapid assembly. Think entire floors slotting into place in days, not months. The core of a 20-story building can shoot up in weeks, not years. On busy sites, up to 10 units can go up daily. Honestly, assembling IKEA furniture probably took you longer. This organized method also slashes material waste by 70%, a massive win for the planet. And while those initial module prices might seem steeper, the faster build slashes financing and labor costs by 15 to 20%. That factory-honed quality control means fewer mistakes and up to 30% fewer problems after people move in. For a 300-room hotel, that shrinks a 2-year build down to just 14 months. For developers, that's a solid 40% faster. Plus, workplace safety gets a huge boost, with 80% of the work happening safely indoors, leading to far fewer accidents. It's a whole new way to build, faster and cleaner, by moving construction inside. The global modular construction market is set to reach $157 billion by 2027, growing a solid 6.5% annually. This growth means it's much more than a fleeting trend. These methods go beyond just speed. They're a major win for sustainability, slashing construction emissions by up to 25% and paving the way for greener cities. We're seeing modular construction pop up everywhere, from London's apartment towers to medical clinics in Africa, now adopted in over 50 countries. Innovations like volumetric modular building and smart factories are really stepping up efficiency, with fully automated assembly lines almost here. These structures are actively reshaping how we plan cities, allowing for the quick deployment of over 10,000 affordable homes each year in some areas. The environmental benefit is huge. Modular projects typically cut construction waste by 70% compared to traditional building. And it gets better. Modular factories optimize energy use, cutting manufacturing CO2 emissions by up to 60%. So, it's not just about speed, it's about a real societal impact, like getting emergency housing or schools up 50% faster. Modular construction uses digital twins, a virtual copy of the whole project, to fine-tune every piece before construction even begins. From Singapore's soaring residential buildings to New York's compact micro-apartments, modular is globally embraced to tackle urban density. These buildings are engineered for the long haul, often outperforming traditional structures with better insulation and strength, easily lasting over 60 years. They also handle earthquakes remarkably well thanks to their segmented design. A Japanese modular hotel famously survived a magnitude 7 quake. This technology has spread across 50 countries, but its influence is stretching much further, constantly adapting for what's next.